wondering if we can first start off with some brief introductions from all of our panelists. Norbert, if you want to start first, I know you've been on the stage quite often today.
Yeah. Hi, everyone. I'm Norbert from ZkCloud. We are building the first universal proving infrastructure for ZK. The first version of the network's been out since, or was released in March 2024. And then since then, we had a scalable network released and coming up with the new one pretty soon. Yep. So we are working with a bunch of zkVM teams and happy to be here supporting Ethereum's snarking journey.
I'm Carlo. I work from Lita. I do cryptography engineering, and we are one of the 25 zkVM teams around.
Nice. I'm Dominik. I'm working for Miden, and we are another one of these 25 zkVMs. Basically, we built it already since a long time ago, and our goal is to build to optimize the zkVM for client-side proofs. So we also built our own instruction set. We have our own hash function, and so it will be interesting to discuss how we can make everything interoperable.
Hello. Yes, this is Ming Guo. Oh, this is better. Yeah. Hello. Yeah, this is better. This is Ming Guo. I'm standing in for Stefan. I'm also from the team ZkM. I'm the co-founder of ZkM. And we are developing a different kind of interoperability scheme called entangle rollup, where we can utilizing zkVM for heterogeneous L1s. Yeah.
Right, thank you so much for the introductions. As our first question, wanted to hear from all of you what roles zkVMs have in enabling trust minimized interoperability. With increased chain specialization, there's many fragmentation that we see, fragmentation across different L2s, for example, fragmented liquidity. How can maturing zkVMs address existing fragmentation?
Well, I think there are very promising approaches. Like as an example, in the Polygon ARC layer, they use SP1 to try to verify from different zkVMs the proofs, and then you can have like interoperability faster than the Ethereum block time. So if you could make it possible, because they are all Turing complete, if you could make it possible that you can verify inside a zkVM another zkVM's proof, then it would like tremendously increase interoperability. Maybe even not only on the block level, but maybe even if you could verify something like a client-side proof from a user on another chain, then it would be even faster. Yeah. But there are also a bunch of problems, obviously.
Yeah, I think in short term, it's not a problem because every scheme of proofs will have their own verifier. In the long term, it might make sense to have a integrated verifier, for example, the one Ethereum might adopt, and then we could probably have a very standardized, like a middleware or something. But in the short term, I think it's a good thing because the diversity of proving system and verifier is actually it's a strength, not a shortcoming, in my mind.
I think that the core of all this panel is going to be about how can I input a proof one zkVM to another zkVM, and that's the way I think zkVM can help with interoperability. And I think it's got a lot of potential and also a lot of technical challenges with them, depending on how different the zkVMs are and the architecture and the proving system and so on and so forth. But I think that there is going to be families of zkVMs are going to be pretty similar to each other that will allow a bunch of different applications that can communicate easily.
I'd go a little bit higher level, I think, because currently we are at Ethproofs. So basically, it's actually in front of our eyes happening how zkVMs can enable interoperability. As soon as we get to real-time proving of Ethereum, then imagine the transactions of different L2s landing in the single block, get proven within the next slot, and then finality times change, interoperability between chains change drastically. The trust assumptions we need for bridging for any type of cross-chain interaction change a whole lot. So like, I'm more on the product side and high level, and I'd leave all the like super technical discussions to you guys on how, for example, one proof of one proof system can be verified maybe in another zkVM or proof system. But like for me, it's super interesting to see what if, let's say, for example, Zeth or RSP from RISC-0 or SP1 respectively, they can prove OP stack even now. They can prove like the EVM and Ethereum even now. Imagine the 7-day finality time of, for example, optimistic rollups decreasing to seconds, or maybe, we could say 1 or 2 minutes, even if we imagine that proving an Ethereum block and proving an optimism block are significantly different because of the large transaction load on the OP chain. But imagine them aggregating transactions for a few minutes, having that proven, having that settled on Ethereum, going from 7 days to a few minutes. That's still pretty crazy. And I think it's just, it's just happening in front of our eyes now. So it's crazy.
And in terms of just making, say, this kind of messaging between zkVMs happen, like what you mentioned with a proof being generated from one zkVM being able to translate that to another type of system, is there any type of coordination infrastructure or kind of middleware that is needed to support this interoperability across different zkVMs, like say with different kinds of messaging layers, or if proof aggregators could come into play here? Any specific types of coordination infrastructure that you see being most useful in this context?
I think that the more than infrastructure, what we need is like kind of social consensus among the different projects to agree on maintaining standardized library and have them as big as possible, I would say. So trying to keep standardized and common, everything that can be standardized and put in common, and maintaining those tools. But yeah, I think that everyone is very, very busy with the developing they have to do. So I think to me, it's more of a social consensus moment in which people agree to coordinate and do something of this sort together.
I could imagine, or if there are different idle computers and someone would put something to be proven there, then I'm sure we need some kind of coordination layer, and these proofs probably need some metadata, like which was the proof system, the field size, whatever. And I would not worry so much about slashing or that we need a blockchain type of coordination. But if it's an open market, then it could be just like an auction or so, where basically you would sell computing power to, I don't know, aggregate proofs or outsource client-side proofs, or and this, I think there are already some experiments with it, like RISC-0 Bonsai, I think is something like this, like a distributed prover network. And I'm sure we will see something like this in the future. The question is, or to me, the question is would they then just run different programs, every prover in an isolated environment? They would just spin it up if the certain proof comes in, or would there be one zkVM somehow that would, such that it would be possible to standardize it, or then could prove these different things to prove in one zkVM.
Yeah, this is actually starting to make sense and actually important, because right now it's pretty simple. You provide a computing service, and you can build it into a market, and the market will basically cover itself. But for layer 2, and of course this is also involved layer 1, the consensus are different. On layer 2, they're not much consensus in the sense that every rollup or every architecture is on its own. It's totally okay. You don't know other people. You assume you're alone in the world. But that's basically how decentralization works. And it will be okay. And no one cares if you died, if you stop your service. Someone else will just continue with their life, their app, their service. But actually, we have encountered this problem that zkVM, we actually built it. I'm really sorry. We actually built a service called Gold Network, and actually it's not on Ethereum, it's for Bitcoin. And when there's disparity of capability, for example, on Bitcoin, the verifier on layer 1 on the Bitcoin main network, it's actually not too incomplete. Like Satoshi actually sabotaged it, in the beginning. And in that case, a very special kind of verifier was developed called BVM, and the whole scheme is kind of difficult, because then you need to enhance the consensus of the layer 2 to supplement all kinds of game theoretic designs to make a wholesome vertical stack that makes the proving system work. In that case, there are multiple roles on layer 2, and then there's gaming situations that needs to build to a very kind of sophisticated economic incentives built in, and then in that case, the consensus become kind of sticky in the sense that there might be disparities between roles, operators, sequencers, and so in that case, consensus becomes actually a very important and crucial part of the whole system design. But of course, that's for the future. And on Ethereum, I think it's totally okay, because Ethereum is very complete and capable. Layer 1, both layer 1 and layer 2. But in terms of interoperability, I'm more interested in kind of just spreading this whole design to kind of extend consensus from layer 1 to layer 2, meaning that with layer 2, you actually extended your consensus because you involve parties that provide compute other than just everyone's on layer 1. And also in this scheme, you can also involve other L1s. This is much more like interesting and exciting. So yeah, of course, we could consider a feature that extend beyond Ethereum.
From my perspective, I mean, just to summarize infrastructure, I think you guys mentioned some prover networks or marketplaces that efficiently generate proofs, some proof aggregator services that would be needed, some messaging protocols to connect ecosystems, some relayers that could relay state on information. But like some other things that just came to my mind, having heard the interview with Justin, is, for example, things like ZK execution layer clients for Ethereum, where if from the next hard fork, it's going to be an option for validators to do, you need those clients to be able to to allow other validators to attest to the validity of proofs. And then those clients would again be, for example, needed on L2s as well, where then they could start verifying the ZK proofs, proving the state transitions of different chains across each other, basically. And actually, in some way, I guess, I don't have the full picture, but something like RISC-0 and Boundless is doing is, I think, something similar, because RISC-0 has the verifiers on different chains. So if I have an application on some chain, I generate a proof for my application using RISC-0, I could actually take that proof and verify it on another chain where the RISC-0 verifier contract is deployed. And that could actually already start unlocking interoperability in that sense. So yeah, actually, I just wanted to tie this whole thing back to Ethereum and what kind of infrastructure in terms of execution clients and whatnot is needed. And it's coming, actually, it's not just needed, it's coming based on the roadmap, yeah, that would allow interoperability.
Yeah, absolutely. And it's really great that quite a few of the panelists here mentioned about just not just on the infrastructure side, but on the like social consensus side, its implications. And even what you mentioned, Ming, about potentially just some disparities with the different roles. But just on that side and just on broader incentive mechanism design, I'm very curious to hear about any sort of incentive mechanisms or pricing mechanisms that zkVMs should use to adopt in order to drive this proof liquidity in, say, these different proving markets. Maybe you have some insight with this, Norbert, from ZkCloud, just accommodating for prover competition, the demand for it, as well as end users' needs.
Yeah, I mean, with ZkCloud, we've been building a prover network, a universal prover network, which can support any zkVM, actually any proof system. Yes, so I think there are a few things to this. I think one of the core things is transparency and predictability when it comes to proof pricing, because, for example, if the finality of a layer 2 depends on the ZK proof, and then we start talking about, let's say, decentralized sequencing, where the sequencers need to source proofs. Basically, most of the landscape has decided, or it seems that's the general approach, to go with outsourced proof generation instead of enshrining a prover network beside the sequencer network in the protocol. So with outsourced proof generation, basically, the mechanism that the third party you are using to source your proofs is very important. For example, in our case, we voted for random selection of prover nodes when we allocate workloads. And I'm talking about workload allocation because most of the predictability and the transparency, I think, is there. And also a lot of risks related to monopoly and like influencing the cost of proving relies there. So we went with randomness, but if we want to choose prover nodes randomly, we need to ensure that there is a uniform minimum hardware for any of them that are in the active prover set. So that's our trade-off, basically, that any prover who wants to join our network has to have pretty beefy hardware or a certain minimum. But then off of this, we can actually, and we have enshrined our economics into the network so that, let's say, someone spins up tons of prover nodes and they increase their chances of being selected to process proving jobs, they cannot influence the cost of proving still, even though they are processing a larger portion of proofs. For example, why with an auction? Just 1 second. With an auction, for example, in a simple reverse auction, but also mostly, as I have seen, in more sophisticated mechanisms, the cost of proving is a large part of the selection mechanism. And as long as the cost of proving is dominant, like any large entity could just come in, do the cheapest bet or the cheapest bid, and could kind of be selected more often and tend toward reaching a monopoly. And with monopoly comes, and with centralization comes, potentially the control over the cost of proving once competition is out of the way, or potentially censorship and many other things. So I think it's a very interesting design topic to explore for anyone who wants to outsource proofs and proof generation. Yeah, but I don't want to talk too much.
Just a question, like you chose random, like you have randomly selected provers, and like the reason is that you don't want that a monopoly arises, basically, that would then run the whole proving network. Is that?
Exactly. So imagine you build a nicely decentralized network yourself, and then you go to a third party which is highly centralized, not because the third party wanted to build the protocol that way, but because the mechanisms that have been, like the architectural mechanisms, the protocol design mechanisms have been such that it allowed others to reach a fairly high level of monopoly, for example, over winning tasks in the network by simply just, let's say, underbidding everyone else if they have the chances to afford that, you know, as a for example, a very rich entity. So yeah, exactly. We wanted to build a network in a way that it's most resilient to any type of centralization risk, so that whoever looks to outsource proving to us, they don't need to take on unnecessary trade-offs, spoiling their own decentralization that they have built in their own protocol. And like decentralization, again, it's a very, I think it's important to mention, most of the time people think about decentralization for proving as something that's not really important. Indeed, it's not important for security, because security comes from math. However, it's important for liveness. If you want liveness guarantees for proving, you need decentralized proving.
Okay.
Yeah, not for security.
Makes
it's for
sense,
liveness.
yeah.
It's good to clarify, because then this puts into perspective why decentralization is also important in proving and not just sequencing and other stuff.
I forgot the question, sorry. Can you repeat?
The question is on just incentives relating to pricing or just any kind of market-driven incentives that can be used to really power proof liquidity across different chains or across different zkVMs.
Got it. Yeah. Like I as a user would love to pay based on like cycles, I guess, and bandwidth maybe. So how big is the proof? And also, like, I would rather pay for hardware. Like, so how fast will the proof be generated? And there are these chips like from Fabric, or there are some others. And like, I think when the proof comes back faster, this is where I would pay more, basically. Yeah. So, well, I don't know.
Yeah, when we use zero-knowledge proofs as a way to scale our existing infrastructure, it become faded into the background, because right now we already have like optimistic rollup. So I think the market will kind of shift to a new kind of asset, which is the proof itself. Also, the computation will create a new kind of asset, and we can call them like native assets. These are assets that's different from asset on layer one, for example, Ethereum or Bitcoin or any layer one asset. We call them like coin-based assets. So the native assets are basically just proofs, but they're not static, right? People would think you can just use this. Many use the same kind of EVM, right? Other chains use compatible EVM, and we just have a same, for example, like a USDT contract on different chains. It's basically the same contract. Can we just reuse that proof? In a sense. But if you treat it as a native assets, it's different. A asset, even the same, like USDT or one chain, is actually very different from the one and other chains. And if you just use that proof itself, it's not going to work, because they mean different. They have different consensus, they have different liquidity. You probably need something like a unified liquidity for it to work. So they're involving condition states, and you also have to pack that into the proof. So the system will probably evolve around trading those new kind of assets that have liquidity across different chains, across different layers. And it's very interesting that what kind of like economy this will entail. And I think the compute market for this is going to be more interesting, evolving forward than just the scalability kind of application that we built this for a couple of years. It will creep into other chains, and the market, for these kind of new asset, this new unified liquidity native assets will probably be a huge deal, and that will kind of foster the market, right, for the need for compute for zero knowledge zkVM that we built today. So probably from this new asset type, and I'm quite excited for that. Of course, there are a lot of new frameworks that sorry for that need to be built. So and those might involve considerations for consensus on different layers, decentralized sequencers, operator validators, because for these different contexts and relationships of roles players, you might want to build different incentive mechanisms as well. So how that evolves, it'll be very interesting to watch.
I personally don't know much about markets, so I cannot really think of a way of market strategy that would like foster interoperability and diversity in the prover landscape. It appears to me that like the more interoperability, the lower the barrier is for prover to join a prover network, and that sounds like a good thing. But I don't know how that correlates with market strategy personally.
Got it. And just a question on when we're able to enable this interoperability between zkVMs, what sort of new applications, new kinds of use cases can we anticipate? You, Ming, were talking about the idea of unified native assets. I'm curious to hear what all the other panelists think about new kinds of applications or use cases that can be enabled.
I think like as a base thing, like for sure, we can redefine how a bridge works. We probably can redefine how an oracle works, like this blockchain infrastructure across different chains with unified zkVMs can definitely work differently, probably cheaper. That would be cool. As a completely new application, I think we also need to change other things, like if just bridge different zkEVMs or so. But this will just give us more block space, I guess, but not different applications.
Yeah, I think the future that zkVM could bring us will, I think the first thing to go, I think, will be the bridges, because we're in the era of DeFi, we all complain about bridges, right? Bridges is brittle, and it's not, basically it's not safe at all, right? It has neither the consensus of either blockchain they're bridging. They're basically like a virus, right? It's not safe. It's even evil. And with this proliferation of zero knowledge proofs across different chains, different layers, we can finally get rid of bridges. So at zkVM, we envision this new scheme called entangled rollup, which we mentioned earlier is called bridges bridge. Basically, with this you can basically utilize precondition instead of sending messages, right? You don't need to send messages anymore because you have the same kind of proof and the same kind of smart contracts. You can build a asset pool, unified assets that guaranteed to be consistent across chains and layers on preconditions. So you don't need message passing. Thus, you don't need bridges. So with this, we can have a much safer interoperability paradigm in this new era. So also we can have a new unified liquidity pool based on this new asset type that basically are just zero-knowledge proofs, and the market comes along with it. So that is a pretty exciting future.
I would also say bridges. I'm sorry to be repetitive, but yeah, and I think also Entangled Rollup is a really cool protocol and project.
Maybe I would add identity solutions where like composable proofs of identity across different chains, or like proofs of whatever could be useful to have proofs of, and then composable among different chains. And I think, like Dominik, it's more related to what you mentioned, like any type of application where the privacy aspect would be useful and like potentially demanded. I think we don't really know yet what changes in terms of, for example, adoption this could bring. I do believe that like there have been voices around this already, and I do share that privacy being available, like Aztec, Miden, different networks are building privacy in different ways, but this could actually unlock a whole new wave of users and adoption, and that could be pretty interesting going forward. And then the composability of maybe all those proofs through like clients, actually that's also part of the infrastructure, like ZK-like clients and whatnot, to allow all those proofs, maybe even the client-side proofs, to be composable cross-chain.
Yeah, got it. So it sounds like a lot of bridging types of applications, and even Ming said that we may not even need to implement bridges in the future. It's also interesting, Norbert, that you kind of mentioned about those identity-related applications as well, and anything that really needs privacy. So really great points that were mentioned here. And I also wanted to ask a question just about general predictions for the prevalence of a standardization of a zkVM. So can we really anticipate a universal standard for zkVMs, or say multiple types of zkVMs dominating the space? You mentioned, Carlo, in the beginning when we were talking about just the interoperability between zkVMs, a lot of zkVM teams, they have very different designs, but similarities between them, and there can potentially be ways in which the proof from one zkVM can also be translated to, say, another. But just curious to hear about general predictions for this future, if when relating to the interoperability for these zkVMs, can we imagine the convergence towards either a single standard or just like similarities between zkVMs, or just the dominance of multiple in the future?
So I think there are some low-hanging fruits. I would expect that zkVM will kind of cluster in some sense. Like for instance, if we think about the zkVMs that use Flunky 3, to have a common ground, it's a lot easier if we only consider those. But if we put in the mix something like Jolt that uses SumCheck, it becomes a lot more complicated, and it can be done. But yeah, so I would expect that these low-hanging fruits of zkVMs have like a strong common ground will coagulate. But I don't know if it's hard to say if like one architecture is going to impose over the other ones, and that's hard to say.
I also think like they will converge just because it's too expensive. Like at the moment, I think we are in an experimentation phase, right? So like we have different prime fields and different hash functions, and like this is super cool. But in the end, it will converge to the cheapest and the fastest somehow. Like and like maybe we will only use Starks or for some reason or only Snarks. And I think another reason that we don't see yet, but I think out of these 25 zkVMs, like all of them have pretty severe bugs, and like we haven't seen them yet. But like it's also super hard to audit them. But then you add a compiler on top, which also will have a lot of bugs. And so like just to make them secure, like this is a very good reason to basically standardize things and use common modules to be sure, that we really prove what we are saying we are proving. And
Yeah, I think this is, we just look back at the old world, right? Even if a very efficient, bug-free, for example, MIPS actually is quite like that, stable. This is mostly like market-driven, right? Like x86 or ARM, they all like win in their own market, not in terms of technology superiority. It's mostly like because of market share, right? You have more market share, that your architecture will just be more prevalent. I think in our world, it's actually better to have more architectures than just we all settle on one. We can probably have one, for example, RISC-V, the RISC-V versus MIPS. I wish it could probably enshrine, just build all these VMs, more popular VMs into the layer one chain itself, and then we just we don't run simulators anymore. But in the end, it would be market driven. And also something like Amazon, like AWS, or we're all using AWS anyway. But AWS in the sense that people who actually want to build their own, horizontal like service that they need to kind of do like but they don't want to like build their own clusters of GPU data center. They could use the standardized service because all the proof system are kind of converge. Then they can do like provisioning and just pick the better ones, more cost effective or efficient ones, based on their own need or ecosystem. So something like that will probably happen in the end. But I don't think like one architecture will rule them all.
I'm good. I think you guys said it all, so I'm good.
Yeah, sounds good. So it sounds like we can expect the convergence on, say, certain standards, but we also have views that multiple architectures will dominate in the future. Okay, that sounds great. Well, thank you to all of our panelists for joining us today for our last panel. So thank you so much for all the insights. Thank you.